Hello, I am RANJITHKUMAR. Today we are discussing about IoT based home automation solution. Abstract home automation using Arduino and Blink application, and also controlling garden lights based on whether it is day or night, and controlling cooler heaters and controlling water levels of a tank based on its capacity. So week 1 we are discussing about C programming and its data types, conditional statements and different types of operators, pointers and functions, string manipulation and storage classes. And we also discussed keywords in that basic data types, modifiers, qualifiers, loops, jumps, and data representation, basic data types, conditional constructs and operators, arrays, pointers. And also embedded C in that recursion, constant with pointers and strings, and also free processors and UDT structures, storage classes. In week 2 we are discussed introduction to C++ classes, object creation and constructor and destructors, introduction to IoT and its applications, installation of Arduino IDE, null modem emulators, Piskin lab and all other required libraries. And week 3 and week 4 we started building our home automation projects. Let's see, go to the introduction to IoT. The IoT is an Internet of Things. It is the network of physical objects that contains embedded technology to communicate and sense or interact with their internal states or the external environment. These devices ranges from ordinary household objects to industrial tools. Within more than 7 billion connected IoT devices today, experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. By means of low-cost computing, the cloud, big data, analytics, and mobile technology, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital system can record, monitor, and adjust each interaction between connected things. This physical world meets the digital world and their cooperate. This is the IoT architecture. Let's come to embedded system. It is a combination of hardware and software which is intended to do a specific task can be done. It has three parts: software, firmware and hardware. Unlike computers, embedded system performs few specific limited tasks. Embedded devices have peripherals such as serial communication interface and serial communication interfaces with synchronous and universal serial bus, multimedia cards, and also SD cards and compact flash. The overview. In this overview, you can see the purposes. The purpose of the document is to understand the requirement home automation using Arduino and Blink application. This document will be used by the students to develop a project. This document will also be used for requirement validation. Scope. The home automation should be simulated on the Piskin Lab simulator. Blink IoT mobile application used to control the devices. Should be able to control the lights, temperature of the home, inflow and outflow of the water in the water tank. Let's come to the assumption and the dependencies of this IoT project. Assumptions: all the peripherals are simulated and no real-time objects are interfaced. Dependencies are based on the Blink app we are controlling devices. Let's come to the requirements. We have software requirements and hardware requirements. Let's come to software requirements. In that, Arduino IDE for the code and Piskin Lab we are using for simulation, and LCD HD44780 and null modem emulator to configure port of serial removal tank, and Blink IoT app for the cloud server. Let's come to hardware. In hardware we are using Arduino Uno, ETHW5550, PCF8574 temperature sensor, LCD SD44780 and LDR sensor and LED. The functional requirements are garden light controls. In this we are going to read the LDR sensor value based on the reading from LDR, varying the brightness of the LED, which resembles controlling garden lights based on the availability of the sunlight. So it works on based on the availability of sunlight, LDR going to works. Temperature control system. The temperature control system consists of an heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. And also, it reads the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on or off the heater and the cooler through the Blink IoT app. By using Blink IoT app, we can control the temperature sensor. It has to be on or off. User interfaces. In that Blink applications, we have Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and also do many other cool things. Creating widgets on mobile. Blink application, button widgets to control heaters, coolers, inlet and outlet valve, gauge widgets to display temperature and volume of the water in the tank on the application of mobile, terminal widgets to display the notification whenever threshold is crossed, or like a temperature is more than 35 degree, and turn off the heater, water level is full, water inflow disabled. Arduino Uno. Arduino Uno is based on the AT-Mega 328P microcontroller. It is easy to use compared to other boards such as Arduino Mega board. The board consists of digital and analog input or output pins, shields and other circuits. The Arduino Uno includes 6 analog pins, inputs and 14 digital pins and a USB connector, a power bank and an ICSP, means in circuit serial programmer. It is programmed based on the IDE, which stands for Integrated Development Environment. It can run on both online and offline platform also. This is the Arduino Uno structure. And also we are using ETSW5500. The ETSW5500 chip is an hardwired TCP or IP embedded Ethernet controller that provides easier internet connection to embedded system. W5500 enables user to have the internet connectivity in their application just by using the single chip in the TCP or IP stack. 10 or 100 Ethernets, MAC and PSEB and PHP embedded systems are connected through it. So it supports power down mode and supports wake on LAN over UDP and supports high speed serial peripherals interfaces also. This is the figure of ETSW5500 model. And also we are using PCF8574. It is a silicon CMOS circuit. It provides general purpose remote input in or out expansion for most microcontroller families via the 2-line bidirectional bus. The device consists of an 8-bit quasi bidirectional port and 12C bus interface. And also we are using temperature sensor in an hardware. So the temperature sensor is an electronic device that measures the temperature of its environment and convert it into the input data into electronic data to record, monitor or signal temperature changes also. Next, the threshold control. When the heater is on, if the temperature is rises above 35 degrees Celsius, then heater should turn off automatically, and the message temperature is more than 35 degrees Celsius, turning off the heater, it should be shown on the display. When the water in the tank is full, turn off the inlet value automatically and display water level is full, water inflow are disabled. So this is the information about IoT based automation. Now my friends Sheikh Mohammed Faiyaz, Nikhil KB and Rakesh KAGI, they are going to explain other things. Thank you.
As we can see, LDR sensor, CLCD programming and the port interfacing. In this, coming to the LDR sensor, we have used set the pin as output pin or input pin. We are using pin mode function where we set is used to set the pin as output pin or input pin. Here in this program we have set pin 3 as output pin and analog pin A0 as an input pin, and we are converting the analog values to digital values by this formula 1023 minus the values of the analog divided by 4, and that analog value is converted to digital and digital value is fed to that pin 3. On that pin 3 we have connected the LED in order to increase or decrease the brightness of the LED based on the value received from the analog read. The digital value is uh, calculated and that digital value is given to pin number 3. And the delay function, this automatic delay we can generate on this IDE by writing 1000 millisecond delay. We can generate a delay using this delay function. CLCD, in this way also we have used some of the libraries like liquid crystal I2C.h, wire.h, and now we are initializing in the setup part. We are initializing the display, so we need to write lcd.int backlight.clear.home, and in order to set the cursor to 0th row and 0th column we need to write lcd.setCursor 0, 0, and then we are going to print hello on the display screen. This is how we can write the program to display any string on the CLCD. Coming to the port interface, we have received some of the temperature value through analog read from the analog pin A0, and that value we are converting into voltage using this voltage formula ADC value multiplied by 5 divided by 1024, and that value we are again converting into temperature using this formula divide by 0.01, voltage divided by 0.01, and that we are displaying it on the LCD screen using this lcd.print. Then temperature should be displayed as a string on the LCD, so we are converting the temperature value as string. This is how we are writing a program for port interfacing. Next, coming to PWM program, where we have generated a PWM signal in order to decrease or increase the brightness of the LED connected to pin number 3. And this blink LED, we are just toggling the LED, we are owning and off, switch off it, and we have given some of the delay so that we can LED can be visible. Blink temperature program, here by wearing the slider on the blink app we are taking that data, converting it to digital value, and then sending it to blink application to display on the widget. Serial tank program, where we have written included some of the modules or libraries, and we are giving some of the defining some of the variables as the in valve, out valve, high float value, low float value, in order to monitor the volume of the tank and to calculate the volume of the tank. This is the program of it. Coming to the Blink application, this is how the Blink on the Blink app, how the widgets are created, create, how to modify the widget, how to create it as a, how to give the pin name, how to modify the pin. Let's look into it. As we can see, click on the new template. Now give the project name. A new project will be created. Click on it. Now click on the plus icon. We can see the many widgets available on it: buttons, icon button, image, virtual slider, and these are all the widgets available on it. We can adjust the cursor or the button just by drag and drop. We can adjust the length, width, height of it, and click on it. And now we need to make it as a push button or a switch. Now click on the data stream in order to give the name to it from V0 to V6 pin, and now give it as an integer or a double or a string in this way, and give minimum value, maximum value, and give the name of the button. And these are all the design part we can do on the Blink application. Now the widget is created. In this way we can create other widgets.
Now my friend Sheikh Mohammad Faiyaz will explain the remaining part.
And we can have the gauges also. We can have some graphs displayed. This is all about the Blink application. Now let's move on to the project programming part, where we have included all the modules. As we can see, we have written a separate blink write function in order to receive the data from the blink. Accordingly, we have switching on or off the cooler or a heater, and in this we are switching on the outlet valve or inlet valve based on the blink write function. We are taking the values from the blink write. On pressing the button on the mobile app, it will be giving us a 0 or a 1 value. Based on that, we are writing a if else statements on which we are switching on or off the heater or a cooler, or switch on the inlet valve or outlet valve, and display the same it on the gauge and even on the LCD display. And we have used some the virtual pin V6, where we are sending some notification to that pin that will be displayed on the Blink application. This is all about the how to calculate the volume of the tank and display it on the LCD and on the gauge of the Blink app.
My friend Rakesh KAGI will explain the remaining part of the video.
Switch on the inlet valve or outlet valve and display the same it on the gauge and even on the LCD display. And we have used some the virtual pin V6, where we are sending some notification to that pin that will be displayed on the Blink application. This is all about the how to calculate the volume of the tank and display it on the LCD and on the gauge of the blink app. These are the different modules: idea.cpp, idea.h, where we are setting the garden light pin as pin number 3 and LDR sensor as A1, analog pin 1. These are the different files from which we have written a code for different peripherals. In this main.h file, as we can see, we have named V0 to V6, as we have included these pins on the blink application, and the same pins we are assigning a name to it. Now let's move on to the project demonstration. And
Now my friend Nikhil KB will explain the demonstration video.
this is how the project looks like. And next, coming to the blink application, this is the blink application, as we can see on the mobile screen. And this is the dashboard. As you can see, we have a cooler switch, heater switch, temperature sensor, outlet valve, inlet valve, and tank volume, and the notification display. And here in this hardware part, we have CLCD display, LEDs, LDR sensor, and Ethernet shield, and we have a heater and cooler, built-in temperature sensor. And let's start our demonstration. This is the serial tank. Now let us switch on the cooler first. As you can see, the cooler is switched on and the fan starts rotating. And we will increase the room temperature by switching on the heater switch through our mobile app. As we can see on the mobile dashboard, we can see the temperature is increasing, and the same is displayed on the CLCD display also. As the temperature rises above 45 degrees Celsius, there will be a notification shown on the display that the temperature has risen to 45 degrees Celsius and we are switching off the heater. Okay, now the cooler has switched on automatically to reduce the temperature to the room temperature. Now let us look at the LDR sensor now. As we can see, when the LDR resistance increases or decreases, the light brightness increases. And let us switch off the cooler and turn on the outlet valve. As we can see, the outlet valve is on and the water starts flowing through the outlet valve. As the volume of the tank reduces below 500 liters, and the inlet valve will be switched on automatically, and we will get a notification that the volume has reduced to 500 liters. As you can see, the water inlet is turned on automatically. So this was the demonstration of our project. In this project, we have learned some of the basic concepts which were really helpful for doing this project, and we have learned how to integrate uh, devices as input and output, how to program it, how to display, how to take the input, how to convert into voltage, how to convert into digital value, and we have seen some of the Pixim Lab simulation tool, which is a very helpful tool in order to configure the devices and where we can see the output virtually. And we have seen the Bolt IoT application in order to create button widgets virtually on a mobile, and how to control the devices using this Blink IoT application. So I thank EMERTXE for providing this opportunity. Thank you.